Here we'll do a problem where we factor and graph a polynomial. The polynomial we'll start with is x to the third plus 4x squared minus x minus 4. We'll start by factoring the polynomial, and since we have 4 terms, let's try factoring by grouping. We'll begin with the first 2 terms, x to the third power plus 4x to the second power. Let's look at what they have in common. Since we have x to the third and x to the second power, the lower of the 2 powers is going to be what we factor out. We'll factor out that x squared because that's the lower power. Then we'll put a parentheses and we'll take x to the third divided by that x squared that we just pulled out. If we divide, we'll get x to the first power, which means our first term inside the parentheses will just be x. We'll repeat this process for 4x squared, the other term, and divide that by x squared also. If we divide, the x squares will cancel out and leave behind a positive 4. We'll have x plus 4 inside that parentheses then. Next, we move to the other set, negative x and negative 4. They don't have any numbers in common, and they don't have any letters in common, but they are both negative. Because they're both negative, we're going to factor out negative 1 from both of them. When we factor out negative 1, we'll divide both terms by negative 1. Negative x over negative 1 will just give positive x, and negative 4 over negative 1 will give positive 4. Now we're almost there. We're just going to repackage the leading terms, this x squared and this negative 1, into their own parentheses. We'll place x squared minus 1 inside of that red parentheses, and then we'll say x plus 4 next to it. Now we're not finished factoring yet because we can continue to factor x squared minus 1 in the red parentheses. You may notice that this is a difference of squares. A difference of squares, where you have x squared minus 1 inside of a parentheses, you can split into x plus 1, x minus 1. That is, we are taking the square root of x squared, that'll give us just x to the first, and taking the square root of 1 and getting plus or minus 1. Therefore, we'll have 2 parentheses, an x plus 1 and an x minus 1. Therefore, our factored form is x plus 1 times x minus 1 times x plus 4. This will be the factored form of this polynomial. We'll carry forward this factored form into the next part of the question. Next, we'll get the x and y intercepts for the function. In order to get the y-intercept, our first move will be to let x equal 0. This means everywhere we see x, we place 0 instead. So we'll have y equals 0 plus 1 times 0 minus 1 times 0 plus 4. When we simplify, we'll have 1 times negative 1 times 4. Multiplied together, this will make negative 4 for our y. This means that our y-intercept will have an x value of 0 and a y value of negative 4. We'll write our y-intercept as 0, negative 4. For our x-intercepts, we'll let each piece of the factored form equal 0. This means we'll set our first parentheses, x plus 1 equal to 0, and x minus 1 equals 0, and x plus 4 equals 0, and we'll solve each piece. This means we're going to move this plus 1 to the other side of the equal sign and change it to negative 1. Our solution from the first piece will be x equals negative 1. This means that our x-intercept will be negative 1, 0, giving us an x value of negative 1 and a y of 0. We'll do the same thing to the second piece. We'll try to get the x by itself. We'll just add 1 to both sides rather than subtracting. When we do so, we'll end up with x equals 1 and an x-intercept of 1, 0. Finally, for our third piece, we'll subtract 4 from both sides. When we subtract, we'll end up with x equals -4, giving us an x-intercept of -4, 0. These will be all of the intercepts for this function. Now we can analyze the end behavior. To analyze the end behavior, we must ask, is the highest order term even or odd powered? We must also ask, is the coefficient in front of that highest order term positive or negative? Let's have a look at that highest order term, x to the third power. Since 3 is an odd number, we'll say this is an odd term. And when you have an odd term, that means that the arrows on either side of our polynomial function will point opposite directions. That means if one points up, the other must point down. We can also see there is no coefficient written in front of the x to the third. Therefore, we'll just use the default value of +1. Since we have +1 as our leading coefficient, this means that our end behavior must be increasing as we go from left to right. So the arrows must point opposite directions, but we must also be increasing. Therefore, the left arrow will point downward and the right arrow will point up. This means on the left side of the polynomial function, we can expect to go down toward -infinity, but on the right side, we can expect to go toward +infinity. With this in mind, let's draw the graph. Now that we've gathered all of our information, let's plot our intercepts first. We'll begin with the y-intercept. We'll plot that at 0, -4. Then we'll plot -1, 0 and 1, 0. We'll also plot -4, 0. We'll also show that on the left we'll go down toward -infinity, so we'll put a down arrow on the left. We must go to infinity on the right, so we'll put an up arrow on the right. So as we draw this graph, we'll begin drawing from the left arrow and work our way to the right, making sure we hit all of the white dots along the way. So we'll draw our arrow, we'll cross through the first dot, we'll continue increasing, but we must turn and hit the next dot. And then as we cross through the y-axis, we must cross through the y-intercept. It's the third dot. We'll make sure we curve back upward and hit the next dot. And then we'll continue on and reach this up arrow. So now we've sketched a graph with all the intercepts and the end behavior.